Oh my God. It's finally happened. Niagara is finally released and production ready. And I felt like this was a pretty good time for me to do another update video, just like I did with UE4 22, where I talked about what the changes were, went through the patch notes, kind of talked about what you can do with some of the stuff that they've added. And a lot of stuff has changed, some real big changes to the layout and the flow of how you work with Niagara. So I will also, in the near future, be doing an update to my Intro to Niagara video, because people have been asking about that for ages. Now that it's production ready, I can finally make that video and not have to worry about a bunch of major changes happening in Niagara, invalidating what I've done already. So that will be coming soon. Don't know exactly when, but keep your eyes out for it if you're looking for an updated intro video. And so the way that I'm going to handle this is pretty much just like I did last time, where I just look at the patch notes here and then dive into the engine and just kind of check out what they've changed. So without further ado, let's start looking at it. And I'm going to kind of jump around here and look at different things based on what I think the best layout is for the video, not so much just the layout that they have things in here. So the first thing I wanted to talk about is they've changed the layout for the stack. So if we go into the engine, first thing you'll notice is that you do not have to enable Niagara. It's just enabled. We're going to create a system here, copy an existing one, just a random one, just so we can have something. And so you can see here that visually, at least from the last time I used it, last time I made a video, they have changed quite a bit. You have this neat little graph that shows off all the emitters in your system, and you can just kind of select things and it highlights them over here. It's actually really handy. A little bit confusing if you worked with it before. It's very different, but it is in the long run going to be a much nicer thing. This is not new to 425 though. What they have changed is they've changed some selection panel stuff that you can do, like you can copy and paste things and rename modules. So if we just take a look at that real quick, you can right click on a module and just say copy, and paste it, and boom, you've got another one. And then if you wanted to, you could right click and you can rename that. So you could rename it whatever you want to. Let's say if you always wanted to rename a module to Hoobastank, you now have a Hoobastank module. So it's pretty nice. You can also just delete things. So it really makes it a lot more versatile and quick to work with things like that, to duplicate modules and whatnot. So this is really nice. It should make moving forward with Niagara much easier. Let's see what else they've changed. They've changed the parameter panel system over here. So at first glance, it's a little bit hard to see what they've changed. If we go back and look at the patch notes here, if I can find it. So here, basically what they're saying they've changed is that they've not organized it by namespace anymore. Instead, they're organizing it by functional labels. I think that's a little misleading because they are still organizing it partially by namespace, but they've added labels such as input, output, reference, and local, which are namespaces or functional tags for attributes that basically categorize them by where they're used in scope. So for instance, outputs are things that you would be using over here, essentially. So like you could have a module that has an output, and then you could read that in somewhere else. Or you could have an input that is specifically only configured at the beginning, and so you just, plop that into somewhere in a module. And so the way that you can use this, and the way that they've changed the parameter panel, is that you can just add in a variable here. And a little gotcha that I've already gotten is that you can right click on the attribute, and then you can go to change namespace, and you can change it and it will automatically move it. So you can see I created it in system and then changed it to emitter and it moved it for me. But where this is a little tricky is if you hit like output or transient, it just disappears. And it took me a second to figure out what was happening. But basically, you can go up here to this little eye and you can click on it and show advanced categories, and it'll show you module outputs. So here's the one I created, transients as well. The other thing that you can do over here is that you can create namespace modifiers So some of these are locked. I can't change them. But if you, same thing with right clicking to change the namespace, you can right click to change a modifier on one of these that is not locked. And I keep clicking on locked ones. Here we go. So all of these are locked. Let me just create a new one. So we're just going to create a linear color in the particle namespace. And then here you can change the namespace to be initial. You can rename your namespaces. So you could, well, let me just clear this. So it's not initial anymore. I can change the namespace and do a custom one. And then this could also be Hoobastank. So that you could have a Hoobastank namespace if you always wanted to do that, or you could name it whatever you want. This gives you a lot of flexibility to categorize things and make sure that your particle systems are clean and readable, and that you know what all your attributes are doing. So let's delete that. So then the next thing we're going to take a look at, which is, I believe, new in 425. If not, it's still pretty new, is the scratch pad. And I don't know what I've done with it here. I had it a second ago. Let's see. Window. Should be able to get, here we go, scratch pad. So if the scratch pad window is not there, it should automatically be there for you when you open up Niagara. But if it's not there, you can go to window and you can turn on the scratch pad. So what the scratch pad is it's basically scripting within the particle system. So as opposed to what it used to be, which is you would go in your content browser and go to FX and you could create a module script or a function script or what have you. And that would be an independent asset that you can share between emitters. This is local to the emitter, just within the scope of the emitter. I'm assuming if you derive a child from the emitter or system, then it will still be there that you can use, but it's really for specialized things that you're only going to be using, you think at least, in one emitter. And it's really good for like prototyping things out. So I can see this quickly becoming like doing all your scripting in the event graph kind of behavior. So, it's the kind of thing that you should use intelligently and not just do everything in. Maybe you prototype things out and then you later refactor them into an actual asset that you can use between other systems if you'd like. So this is pretty nice. It's all nicely encapsulated within the Niagara editor, but it's also very similar to like working in blueprints. So it looks kind of like a function. You have your inputs, your outputs. You can create multiple different modules up here. You can create dynamic inputs. You can look at all the attributes in here. And then there are also things down here that you can look at that are specific to how you're going to be using the script, the module that you're creating. So for instance, they talk in the patch notes about, if I can find it, scopes for module creation. And so basically they're talking about how the system scope flows down to the emitter scope, which flows down to the particle scope, and that affects namespace and attributes as well. But you can go in here and actually say, like, what is this module going to be used for, just so that you have things, organized correctly and that you know what you're doing. So I think I covered pretty much everything in the scratchpad that I wanted to, except that they have also added a pretty neat new feature, which is called a particle attribute reader. So basically what this does is this allows you to access attributes from different particles, be it within the same emitter or the same system. And the way that it kind of talks about this is it says that if you're accessing from within the emitter, it's reading from the last frame or last tick. So it's reading basically slightly old data just to get an idea of what that value is. If it's reading from a different system, then it actually simulates the other system first, and then it reads that data. So I'm not really sure how that works if you're trying like two systems or two emitters within the same system trying to access each other at the same time. I don't know if that's just an infinite feedback loop or something, but it's just something to think about. But anyway, so the way that this is going to work is if you go on the scratch pad here, you can make new scratch module, which I've already done, and you can click add and you can go particle attribute reader. and you can add that. And so this is basically like getting a reference essentially to particle attributes. And then you can get, for instance, a float. You can do it by particle ID. You can also do it by index. So I'm going to get float by index. You can say what the attribute is. So basically you're naming it whatever the attribute is that you want to read. And then we can do something like execution index. We just plug this in, and basically what this is doing is it's getting the index of a particle that's being spawned. And so you plug this in, and then you can say whatever you want, like, I don't know, like age or something. And then you would basically draw this off, and you can output it as a value. And essentially what that would be doing is like reading the age of the particle as it spawned, which would not be super useful. So you could do something like mass or something like that. But basically then you're just getting that data from that particle, so that you can then say, I'm going to use this somewhere else to inform something. Like if you wanted to get a vector that was the position of the particle, then you could do things like draw ribbons between particles and things like that. So pretty powerful, pretty cool. I can see a lot of really cool ways to use that. So that is most of what I wanted to show in here, most of the big things. There are a couple small little things in here like Niagara effect types. So if we create one of those, you can look and see that this is basically a bunch of scalability and update settings. So you can define all of these things, and then you can go in and say, I believe it's in system properties. You can go into system properties, and then you can set that. So basically this is like setting a group or a collection of scalability settings that you can then use to customize or standardize scalability across different types of effects. So you could say, like, I want all of my like bullet impact effects to be pretty scalable. And so like when you crank the graphics down, like they get hit pretty hard. But other things like, you know, things that are important that all players see, like if somebody throws a smoke grenade, you want that to still show up and still have pretty good scalability settings. Then you can set all those kind of like visibility impairing effects to have, you know, pretty high scalability, so that they're not like actually disappearing when they're on lower settings. And then also on scalability stuff, if we look at the emitter, I believe it is emitter properties. Yeah. So emitter properties, there's scalability in here, but now the interesting thing is that you can add platforms. So you can basically say, like, if I'm doing something on Android, I want it to be low on the scalability settings. If I'm doing something on Windows, I want it to be over here on Epic or whatever. So basically you can easily set out at the beginning of your particle system how it's going to act on different platforms to affect performance. So that's really cool. That's really useful and makes scalability way easier than it ever was in Cascade. So all those things combined together should make it a lot easier to come up with like LODs and things like that are not a total pain. And finally, probably one of the coolest things that they've added, but that I'm not going to spend a lot of time on just because I haven't had the time to really mess with this, is this audio oscilloscope and data interfaces. So basically, as you can see here, I've got this muted, so you can't really hear, but it is a YouTube video and I don't want to get like struck for it. But essentially, these particles are reacting to the audio. So it's this little song that's playing. It's really cool. I can see a lot of cool things being done with this, just visualizers and things like that. So this I might make a tutorial on in the future just because it looks so cool whenever I might get the time to be able to do that. But it is really neat. So that's a really cool thing that you guys can start playing with now. And outside of that, this is all that they have really, or all the major changes anyway. I'm sure there are some smaller things that have been changed. And certainly there's a lot that has been changed since I last made a video. So like I said, I'm going to be remastering, quote unquote, that intro video and putting that out sometime relatively soon. And outside of that, I hope this was informative or educational or helpful in some way. If you liked, make sure to give it a like and subscribe, all that good stuff. Comments if you have any questions or any suggestions. Also, down below, I have links to my Twitter, YouTube, and I have also created a Discord for my own game projects, as well as for this community tutorial kind of stuff. So if you want to come discuss tutorials, or if you have questions about my tutorials, you can come there and ask me personally. So anyway, I hope this helped, and I hope you have a great day.